For nearly a century, cosmology has operated under a kind of silent agreement, an elegant, mathematical, powerful narrative, a story that seemed to explain absolutely everything we see in the sky. It shaped textbooks, guided telescopes, directed space missions, and even secured Nobel Prizes. This cosmic script has a name: the Lambda CDM model, the true operating system of the modern universe. But what if that system is beginning to freeze? What if the latest data are the equivalent of error messages coming from the cosmos itself? At this very moment, an observatory floating about 1 million miles from Earth may have begun to expose deep flaws in the foundations of cosmology. These are not minor inconsistencies or fine adjustments. They are cracks running through the pillars of our understanding of the universe. The James Webb Space Telescope is seeing something no one expected to find. But before we dive into this cosmic crisis, don't forget to like and subscribe to the channel. As it peers into the farthest reaches of space, it also looks back in time, to the earliest chapters of cosmic history. And there, where simplicity and darkness should have reigned, it found structures far too complex, far too massive, and far too ancient to exist. Objects that appear to break the very timeline of the Big Bang itself. Today, we will explore why some Nobel Prize winners are quietly admitting that the primordial universe looks nothing like we imagined, and why a once unthinkable question is beginning to surface behind the scenes of science. Did the universe truly begin the way we believe it did? For decades, the Lambda CDM model has been considered the gold standard of cosmology. According to it, the universe is governed by two invisible ingredients: cold, dark matter and dark energy. Together, these forces determine how galaxies are born, how they evolve, and how space itself expands. Within this framework, the early universe should have been silent, simple, and profoundly dark. An era when matter was only just beginning to organize itself. We call this period the Cosmic Dark Ages, a phase shortly after the Big Bang when no stars or galaxies should yet have existed. Then we turned on the James Webb Space Telescope. Webb does not merely observe unimaginable distances, it observes the past. Every point of light it detects began its journey billions of years before the sun even existed. And when it aimed at those ancestral regions that should have revealed the universe in its infancy, it found something entirely unexpected. Instead of darkness, it found structure, it found motion, it found enormous, luminous objects that were already fully formed. They were not the small, faint, primitive clouds of gas predicted by our models. They were thousands of objects far too bright, far too massive, and far too dense. Astronomers examined the data and repeated the same phrase: "This cannot be right." Webb is detecting complex structures where complexity should be mathematically impossible. It is finding objects that appear far too mature for a universe only 13.8 billion years old. This is not a data error. Independent teams around the world are seeing exactly the same thing. The cosmic operating system has frozen. And here is why this is a nightmare for physicists. The Lambda CDM model provides a very rigid timeline for the growth of the universe. It states that the first galaxies grow slowly, accumulating matter over vast stretches of time, and forming stars gradually, piece by piece. Based on everything we know about gravity and dark matter, there simply would not have been enough time or material for massive galaxies to emerge, just a few 100 million years after the Big Bang. It would be like walking into a nursery and finding a fully grown adult wearing diapers. The timeline collapses. Yet Webb is observing galaxies so large and so dense that mathematically, they would require more matter than the universe should have been able to provide at that stage. The numbers do not add up. The physics does not add up. A study published in the Astrophysical Journal identified 87 candidate objects that may have existed only between 200 and 400 million years after the Big Bang. To put that into perspective, confirming even a handful of them would already pose a serious problem for cosmology. One of the researchers, Haojing Yan, stated directly, "If these objects are real, our understanding of early galaxy formation is fundamentally wrong. We are not merely rewriting a chapter of the book. We may be discovering that the book is written in the wrong language. As if impossible galaxies were not enough, the details grow even more unsettling. In the present universe, galaxies are surprisingly inefficient. When a galaxy forms, only about 10% of the available gas is converted into stars. The rest remains as gas, ready to fuel future generations of stars. It is a slow and steady burn, but Webb's data suggests something radically different for these ancient objects. Some appear to have converted 100% of their material into stars. Think about that. No leftover gas, nothing to fuel future growth. That level of efficiency should not be possible under any known physical law. This has forced scientists to ask uncomfortable questions. Are these even galaxies? Or are we witnessing a new class of cosmic object that fits into no existing category? If they are galaxies, the implications are staggering. It would mean that the Big Bang model, as we understand it today, is incomplete, or worse. Perhaps the universe evolved faster than our theories allow. Perhaps gravity behaves differently on cosmic scales. Or perhaps the universe we see is only part of a much larger reality. To understand what might be happening, we need to step back and reconsider how the universe itself behaves. In 1929, Edwin Hubble made a discovery that changed everything. Galaxies are not scattered randomly. They are all moving away from one another. Space itself is expanding. And here is the strange part. This expansion has no center. Wherever you are, everything appears to be moving away from you. Every observer sees themselves at the center of expansion. And it is not just expansion, it is acceleration. The farther away a galaxy is, the faster it recedes. Eventually, we reach a boundary where galaxies are moving away at the speed of light. That boundary is called the Hubble sphere. Beyond the Hubble sphere, galaxies recede faster than light. This sounds impossible, but nothing is breaking Einstein's cosmic speed limit. It is space itself stretching, carrying galaxies along with it. As the universe continues to expand, the Hubble sphere grows over time. This means that light from some galaxies that were once receding faster than light can still reach us. Their photons climb a cosmic escalator that lengthens as they travel. However, there is a final limit. That limit defines the observable universe, an immense bubble about 92 billion light-years in diameter. Everything beyond it remains forever hidden. The most distant galaxy ever detected, Jade's GS Z14-0, comes from an era when the universe was only 290 million years old. But here is the twist. That galaxy is no longer observable today. It has already passed beyond our horizon. Whatever it has become, we will never know. The observable universe is not the entire universe. It is only our local window. If the universe is infinite, and the evidence increasingly suggests that it is, then the Big Bang did not happen at a single point. It happened everywhere, all at once. That means that far beyond our horizon, there are entire regions of space we will never see or influence. Yet Webb may be catching hints of what lies beyond. To understand why these impossible galaxies are breaking our models, we must correct a major misunderstanding about the Big Bang. Most people imagine an explosion at a single point, with matter spreading into empty space. But that is wrong. If the universe is infinite, and the evidence increasingly suggests that it is, then it has always been infinite. The Big Bang did not happen at a single point. It happened everywhere, all at once. Matter did not appear in one location and spread outward. It emerged throughout all of space simultaneously. This helps explain the cosmic microwave background radiation, that faint glow we see in every direction. It is the light from that event reaching us from all sides. But here is the problem Webb has introduced. If the Big Bang happened everywhere and the universe should have been a hot, uniform soup cooling down, then gravity should have taken hundreds of millions of years to transform that soup into the first clusters. Instead, Webb is seeing structure where there should only be soup. It is like baking a cake and opening the oven 1 minute later to find it already decorated with frosting. This suggests that perhaps the ingredients were already organized before the oven was even turned on. And it is not just a few YouTubers making wild assumptions. The panic is happening at the highest levels of academia. Some of the most respected physicists in the world, yes, including Nobel Prize winners, are quietly admitting something extraordinary. They are analyzing data from independent teams around the world and realizing that the early universe may not have looked anything like we imagined. For decades, suggesting that the Big Bang was not the absolute beginning was career suicide. It was fringe science. But Webb's data are so disruptive that scientists are now considering ideas that were once taboo. They are evaluating a far more radical possibility. What if the universe did not begin the way we think it did? What if those distant objects are not primitive galaxies at all? What if they belong to something completely different? This leads us to the most astonishing theory gaining traction: cyclic universes. The idea is simple, but terrifying. What if our Big Bang was not a beginning, but a rebound? What if our universe is just one in an infinite chain of universes expanding and collapsing, or fading, repeatedly? Some physicists are looking at these impossibly bright objects discovered by Webb and asking whether they could be remnants. Could they be structures that predate the Big Bang itself? Imagine a previous cosmic epoch that ended, leaving behind seeds, supermassive black holes or dense knots, that survived the transition. When our Big Bang occurred, those seeds would have instantly jump-started galaxy formation. That would explain why we see massive, fully formed monsters only 200 million years after the beginning of our timeline. They did not grow from scratch. They had a head start. They are ghosts of a previous reality. If that does not sound wild enough, there is another possibility being taken seriously. A Nobel Prize-winning physicist openly suggested that Webb may have found evidence pointing beyond our universe. Remember, the observable universe is only our local bubble. If these primitive objects are too large and too fast for the laws of physics within our bubble, perhaps they are being influenced by something outside it. Perhaps the universe we see is only part of a much larger reality. Just as a fish in an aquarium sees shadows moving outside the glass, Webb may be detecting the gravitational influence of structures that exist beyond our cosmic horizon. This suggests that what we call the universe may be only a small patch in an infinite and timeless fabric. If we set the multiverse aside for a moment and look at pure physics, the situation becomes even worse for the standard model. It is not just about when these galaxies formed, but how. In the universe we understand, governed by standard thermodynamics, forming a star is chaotic and inefficient. In normal galaxies like the Milky Way, there is plenty of gas, but only about 10% of it collapses to form stars. The rest is expelled by radiation, or remains as dispersed fuel. But Webb is observing these ancient monsters and seeing something that defies logic. The data suggests that some of these objects converted 100% of their material into stars. It is the nightmare of efficiency. Imagine putting about 1 gallon of fuel into a car and achieving millions of miles of range with no heat loss. That should not be possible. In these galaxies, there are no leftovers, no gas, nothing to fuel future growth. If these data are confirmed, it means the fundamental laws of how matter collapses under gravity laws we believed were universal, may not apply to the early universe. This leads us to the second possibility physicists discuss in hushed tones. If the timeline is impossible, and the efficiency is impossible, perhaps the force driving them is wrong. The lambda CDM model depends on dark matter as the glue that slowly binds galaxies together. But Webb is seeing things happen too fast for that glue to work. So scientists are forced to ask, what if gravity itself behaves differently on cosmic scales? We assume gravity is constant, that it works today the same way it did 13 billion years ago. But what if it does not? What if gravity in the infant universe was stronger or operated under different rules that accelerated structure formation? It sounds like science fiction, but by adjusting the strength of gravity in the equations, those impossibly massive galaxies suddenly become possible. The problem? We would need to abandon Einstein's general relativity as the complete description of the universe. We would be admitting that our cosmic operating system needs a massive update. This leads to a troubling realization. The Big Bang model, as we understand it today, is incomplete, or worse. We built a house on a foundation we thought was solid rock, but Webb is showing it may be sand. If physics does not work and the numbers do not add up, we are not just losing a planet or a star. We are losing a fundamental mechanism of reality. Some researchers state directly that our understanding of early galaxy formation is fundamentally wrong. We are seeing a universe that evolved faster than our theories allow. This forces us to confront the fact that the observable universe is not the entire universe. We are trying to deduce the rules of an infinite ocean by studying a single glass of water. To grasp the magnitude of this, we must remember that we have been here before. Before 1929, the smartest people in the world believed the universe was static and unchanging. Then Edwin Hubble proved it was expanding. That discovery destroyed the physics of the time and rewrote every textbook. Now history may be repeating itself. The idea of an expanding universe once seemed extreme until it was proven. Today, the idea that our physics is broken or that structures existed before the Big Bang seems extreme. But data do not care about our feelings or our Nobel Prizes. We do not have answers yet, only data. And Webb's data are shouting that the universe is not finished, surprising us. We are on the edge of another moment like 1929. So what happens now? If Webb has already shaken physics just by peeking into the early universe, what will happen when it truly looks? The telescope is being pushed to its absolute limits. Astronomers are targeting the era known as the Cosmic Dark Ages, that mysterious period shortly after the Big Bang when no stars should exist. The goal is terrifyingly simple: find ground zero. If we look 200 million years into the past and see monsters, we must look even farther, to 100 million, to 50 million. Webb is hunting for the moment when the impossible ends and the normal begins. But there is a fear that keeps scientists awake at night. What if it never ends? If Webb observes the absolute infancy of the cosmos, when the universe should be nothing but hot soup, and still finds massive organized structures, then there will be no fix for the model, no adjustment to gravity. That would prove the universe's structure was inherited from something before the Big Bang. It would mean we live in a recycled cosmos. We are in the middle of a war of data. We still do not have final answers, only mounting evidence. But that is about to change. In the coming months and years, Webb will move beyond simply finding these objects and begin analyzing them chemically. It will reveal what they are made of. Are they truly galaxies filled with stars? Or are we witnessing an entirely new class of cosmic object? Perhaps they are dark stars, monsters powered by dark matter instead of nuclear fusion. Perhaps they are seeds from a previous universe. One thing is becoming increasingly clear: the story we tell about the cosmos may be only the beginning. The universe is not finished surprising us. The Webb telescope has turned on the lights in a dark room, and we are realizing we do not recognize the furniture. And as it continues to look deeper into space and further back in time, we may discover that the universe is not only stranger than we imagined, it is stranger than we can imagine. So where does that leave us? For 100 years, we believed we had the map of the universe. We believed we knew how the story began and how it would end. But the James Webb Space Telescope has just reminded us of the most important rule of science. The map is not the territory. Right now, we do not have all the answers. We only have data. And the data are telling us the universe is not finished surprising us. If these objects are impossible galaxies, dark stars, or relics from a time before time, they are proving that the story we tell about the cosmos may be only the beginning. The universe just became far more interesting. If you want to stay on the front line of this scientific revolution and see what Webb discovers next, be sure to subscribe to the channel and turn on notifications. Because if physics is broken, we are going to need everyone to help fix it. Thank you for watching and keep looking up at the sky.